Hey, how's it going? So, well, first off, here's the problem that I have. I'm working on this story right here, and I noticed that there was a repeated sentence. So I don't really know how I did that. I don't know if it was a copy paste error or how bad it is, but it does seem like there's some repeated phrases. I just want to make sure that things are in line. Let me get rid of my drink here. Oh, that was loud. Okay, but I need a basis of comparison. So I was going to look at the pile here. This is like over a terabyte of text. It's compressed, and it's kind of a pain in the butt to get out. So where are we? So I have this thing called read every ZST file, and I mean, it could run for days, even if I ran it on multiple cores, trying to process everything. It's just not reasonable. But I realized that this extracted a bunch of what I called snippets. Basically, it's just extracting the text. So I don't really even need to. I don't need to look at the ZST files. I can just read these text files directly. So let's do this. I'd like to start a new project. This one is a little bit insane here. I'll call it Look for Overused? I don't know. I'm really bad at naming things. Sure, whatever. Yes. Okay. Why doesn't it create a main.py? I don't understand. Does it really think that I'm not going to need one? Okay, so path equals that. And, Hey, thank you. Yeah, that's exactly what I wanted. So, ends in .txt and file name starts with B. Here, let's just see what it's given us here. Boom. Okay. Yeah, so we are going to God. It's just a little overwhelming. It's just writing the code for me. All right. Let's see here. Total equals 0. Start time equals time.time. End time equals time.time. Yeah, so just say, I don't know, elapsed time. I'm curious how long it takes to read all of this stuff. So we'll say total and then total plus equals that. Should be about, I don't know, a few hundred megabytes or something. Boom. Carmap codec. TF8. Run. Alright. Hopefully this doesn't take too long. Yeah, so that's about what I thought. And is it going to go faster if it's in cache? Yeah. Yeah, it will. Alright, so I'm hoping that we can use this as a basis of comparison for figuring out which what am I trying to say? Like, which words are used the most commonly. We'll call those 1 grams or, just single word count, I guess. N-grams is more 2 or 3 different words. So we need a tokenize method here. So def tokenize st. So st equals st.lower. like we did this. I feel like I made a tokenized method like this very recently. Oh well. So new string equals, yeah, I if I dot is alpha, else space for I and st dot lower dot join dot split space. Okay. Yeah, j for j in that if j dot strip. Okay, so that should give us just very basic tokens. So we'll say print ns. I want to see what it looks like, and then we will immediately exit because I don't want it to run and print everything. That would be insane. It helps if we call it tokenize content run. Yeah, okay, so this is the tokenization that it's giving us, and let's see how long it takes if we run that through a counter. So we will say c equals counter of ns. Print c, just make sure that it's doing what we want. IV to my, yeah. And, all right. Hopefully this runs pretty fast. It's going to be pretty annoying if it takes forever. Probably should have benchmarked it first. How many files are there? That ain't it. Okay, 24 seconds. That's not too insane. Yeah, I was worried that all this nonsense would take longer. Okay, so what we want to do is we want to base frequency based on the number of words that that appear, and then we want to know what the different quartiles are. So we are going to have all words equal. Okay, first off, I would like to run this in like some kind of debug mode. So we'll say debug mode equals true, and then if debug mode and secrets dot rand below 100 equals 7, so in other words we're doing 100th of them, then we'll do it. So that should definitely speed things up, right? Should take this down to about 1/4 of a second. All words is going to be a default dictionary of type list. And we are going to run. Okay, not quite the 1/4 second that I thought, but you know what? Maybe it's not all in the processing. Okay. So let's gather all of the words. So yeah, total words equals length of ns. I guess we could have done sum of values. Yeah. So we're going to go for c in all words dot items. What in the hell? For CNT, comma, word in C dot not most common dot items. We're going to say all words of word dot append CNT divided by total words. Right? And then from this, we should be able to get, the median count and the, third quartile count. Let's see how this goes. Unsupported operand type for string and integer. CNT, total words. Did I get this backwards? Yes. Yes, I did. Not sure how I managed that. Okay, so print all words. No, just print it down here. Print all words. All words. It's probably going to get pretty insane. Yeah, so magic. Oh, imagine that one not being very common. Okay, and then we have to remember that the incidence is 0 for things that don't appear. So, yeah. How are we going to do that? Well, we need to remember the total number of processed files. Processed files equals 0, and then processed files plus equals 1. Okay, and then for any given word, we should be able to find out the median and the quartile. Okay. Find median quartile. It is a list. Yeah, num items. So, you know what? I have a feeling that this is a job for ChatGPT. So for comma ARR in all words dot items ARR dot sort. All right. So let's come in here. I am storing word incidents in Python. But there's a twist. There are implied zeros at the beginning of files that did not contain words. Write a method which finds the median and third quartile and 90th percentile incidence of words given an array with a number of files understanding that if the number of files is greater than the length of the array, that there are implied zeros at the beginning. The array is already sorted. Okay, calculate percentiles. I think that's how I would have done that, but that's fine. Calculate percentiles, find percentile. So that's fine. Okay, let's test a few different words here. We're going to say all items. Oh, I can specify the percentile. Oh, you know what? That is actually better. Full data. Sorted data, percentile, full length. Yeah. Let's modify this ourselves. Sorted data minus 1 times percentile. Int k. C equals k minus f. Length of sorted data, no. Full length minus 1. Integer of this. Yeah, I don't know why we wouldn't just start with an integer. Yeah, and then this is going to be minus the things that are missing. So minus full length minus length of sorted data, which if they're the same thing, it's going to be minus 0. Yeah. If k is less than 0, then return 0, which I think is going to happen quite a bit. Assert k is lesser than length of sorted data. Return sorted data of k. Maybe I'm a little smarter than ChatGPT, or maybe I didn't explain myself very well, or maybe it's a damn weird problem. Any of these is possible. So find percentile of, let's try an extremely common word, like all words of the. And the percentile we're looking for is the 50th percentile, and the full length is processed files. So we're going to run, and do I still have an exit in here? I don't. Oh, I found a percentile. Print. Run. Okay, so the incidence is 0.059, so very roughly 6% of words, right? And then let's do a much rarer word like, well, let's find out if we put in some nonsense. So that should be, it should return 0. And then let's do Jeremy. Can't be capitalized. Man, I want to see what this does. 0, 0, 0. These are all 0. Now, what if we went 90th percentile, 99th percentile, 999th percentile? You know, because, I mean, that is a somewhat common word. Okay, so the incidence is pretty low. Oh, look at that. Did I push it off the edge or something? No. I'm confusing it with this. Okay, so the 90th, 99th, and 999th percentile are, well, it's probably giving me the same data point. That's understandable. Okay, so now what if we had a more like generic word like pink? Run pink? Interesting. Okay, so it is much less common, but it does exist. So, yeah. So what I want to do is I want to compare my document, and then I want to see if there's just some word that I just... Yeah, well, I don't know what the cutoff is. 90th percentile, 99th percentile, 999th percentile. Let's do it. All right. Now, right now, this takes all words, right? And so we would need to copy it. So all words equals original equals all words, right? Reference equals now we start with all words again. Reference equals all words. And then we need to load my story in. This is definitely not the right way to do this. Nobody should be learning how to code from me. A terrible violation. Okay, so story so far. Yeah. Then we're going to say tokenize file name equals boom. And oh man, it's already getting late. Yeah, we're not doing 2 and 3 n-grams tonight. But you know what, just word frequency, that's fine. Because I'm kind of curious. Tokenize, where do I call it? So, yeah. Dot read. That's all I do, and then I pass it in. And now let's put the all words back. All words is original. And then I want to compare. So we are going to say for word in all word, no, in reference dot items word comma array, and then quantity, it should be at most 1, so ARR of 0. Yeah, and then we want to compare it with, I don't know, the 99th percentile, right? So say the 90th percentile. So reference value equals that. And, oh my god, I'm alternating this. Comparison. And then we will print quantity. No, we will print word, quantity, comparison. For reference, that should be every word that we have. What in the hell? Did I do this backwards? Yeah. All words is original. I don't understand. Wait. I don't understand how this worked at all if the file is wrong. Okay. Path file name. Oh, it's not file name, it's FN. There we go, there we go. So yeah, now what I want to know is if QTY is greater than comparison, then that. And that should be things that are potentially overused here. The. Now what if we went to 99th percentile? The Lone Hunter. Sun. You know what? Sun is one of the things that I really did think might be overused. Go 999. There's too many things here. Oh, well, we're still in debug mode. Here, 99th percentile should be good enough. Assertion error. K is less than length of sorted data. That could be a rounding issue. If K is greater than or equal to length of sorted data, then K equals length of sorted data minus 1. If K is less than 0, then return 0. If length of sorted data equals 0, then return 0. Chapter. The. Oh, now come on. The? It doesn't have the? Okay, I must have, like, erased my data or something. If length of sorted data is 0, then return 0. If K is less than 0, then return 0. That's right. If K is greater than length of sorted data, 0, 0, 0, 0, 0. Why? Why? Show me all words. I must have erased all words somehow. Oh, I see what happened. Or not debug mode. It's ironic because we just needed a little bit of debugging. Okay, now this will take a few seconds. I don't actually know how long it's going to take. Have we ran the entire thing yet before? Well, it was taking less than 1 second when I was doing 1/100th. Okay, so there's not much that can be done if there's no reference. But what I would really like to know is, okay, now, if comparison equals 0, I don't know why it would be less than 0, but if it's less than or equal to 0, then we just have int.infinity or math.infinity. Else we have quantity divided by comparison. How long did this take to run? 30 seconds. Not the end of the world. Okay, so my data equals list right here. And then my data dot append put this in here. My data dot sort. And then we're going to say for word, comma, ratio in my data, print word, comma, ratio. And we'll see what this does. Should give us some sort of an idea of which words are the most overused. Sun was one of the ones. I just like every single chapter starts off. The sun was dipping low. The sun was setting. That it's like, oh my god. So let's bring the story up here. Now it says Waypoint reignited McAllister, Marsden, Homesteader, Grabbers, Frontlines. Grabbers. One time. I think that's probably fine. Lena, Settlers, Unbreakable. Now this is one that I actually did think was overused. So let's take a look. 1, 2, 3, 4. Oh my god. 5, 6, 7, 8. Hey. No, this is actually valuable. This is good. I can work with this. Now look, not every one of these is necessarily, like a big deal or something. What is going on? These are supposed to be sorted. It's because the ratio is backwards, isn't it? Word ratio. I just labeled it wrong. Yeah, but it's still sorted wrong. I am so confused right now. Math.infinity, comma, word, right? My data. Ratio, comma, word. I think I was getting confused because of this output right here. Now, obviously, if I were going to keep running this, I would need to store this data. I can't generate it live every time. 30 seconds is killing me. And that's exactly what I intend to do. When I do the 2 grams and the 3 grams, I need to store that information. All right. Okay, so settlers, unbreakable, rekindling, unforgiving. You know what? I might have a list of the total number of times that it appears to try to make a decision. Because if something only appeared, oh yeah, look at this. This is completely legit. All right, cool. I would say that is a success.